Welcome. We are going to do in this video some exercises on vector decomposition. So when I instruct you to do so, please do stop the video, try to do the exercise and check with the answers that I will provide you. The first thing we are going to do though is we are going to review components a little bit, just to set notation and to also give you a little bit of practice, warm up to what we are going to do. So this is a vector right here. And you should remember that the idea is that vectors have some magnitude, so we can talk about how big they are and their direction. So this is my vector, but it is very useful to have a grid, to have a reference system that will allow me to set a scale and to speak about that direction that I want. So there's my grid. Cool. So now I can actually say, for example, that this vector, well, it looks a little bit to be in the x direction or the y direction, and I can say how much it is in each of those directions. So first exercise, remember this part from lecture. I'm going to ask you to write the this vector, let's call it A, in IJ notation. So pause your video and do the exercise in your notebook. Maybe go around, get your notebook, and then we'll continue. So please stop the video now and carry out the exercise, and we'll check in a second. So you're back, and then you did the exercise as I suggested to you, and let us write it then. A, vector A, is going to be equal to 3i vector and 1, 2, 3, 4, 5j. So you just count the boxes, and there it is. Good. So now I want to remind you that how do we think about these components, and just add a little bit more of notation. What you just did right now, if you got that exercise correct, or if you look at the cheated and look at the solution but still made sense to you, please note that what you did was to look at this rectangle that is right there. So look at that rectangle. And that's what helps you to determine that you had 3 units in the horizontal and 5 units in the vertical. So that's what we are going to repeat later when we do the composition. Actually, I'm going to do one more thing to further explain this. And note that I added 2 green vectors here, one in the horizontal and one in the vertical. And here they are again. So this is the picture I have right now. And I want to tell you about thinking about components in this particular way. Exercise, please, you're going to pause the video and take a look at the geometry here and show me that you can actually form the red vector as the sum of these 2 vectors. For this is an exercise you do in your notebook. You're going to draw the vectors as a sum, because remember, if you want to sum vectors, what you do is you add, well, you first draw one vector, then you draw the second vector at the end of the first, and then the result is obtained by joining the original point to the end of the last vector. So try to do that. Show that these 2 vectors really add up to the red. Good. Pause your video, and when you're ready to come back, we'll continue. And we are back. So let's take a look at what your answer should have looked like. Hey, this is there are 2 ways to do this exercise. So note that I took my 2 vectors, this one and this one. The greens add up to the red. The green, so we take the vertical and the horizontal and we join, and both of the 2 cases add up to the red vector. So the point of this is to add even more notation, to make these things even more hopefully clear and precise. So let us call this vector is A, and now as you can imagine, this H is for horizontal, and this V is for vertical. So that we have as vectors the vector A is equal to the sum of the vector H plus the vertical. And one more thing, the way we ended up with this representation that you got correct in the first exercise we did, right here, where did it come from? It came from adding these two vectors, the horizontal and the vertical, that you just showed that they really add up to A. And each one of these, H, and V, have a very simple representation in I and J. So in H is just the AX value. This is a scalar, this is a number, this is 3 in this case, and A sub Y, which is 5 in this case. So take a look at all these equations. They should make sense to you, but they are occasionally confusing, and it requires practice to go from one expression to the next. So we have A as 3i plus 5j, and then I ask you, what is A sub x? Well, that's 3. A sub y is 5. So this H is A sub x I, because then it's a vector. This is a number, but then together this is a vector. And this is A sub y j. So this is a number and this is a vector, and it gives me the result I want. Exercise. Yeah, just write the components of C, of the vector C. So here the task is for you to tell me what is Cx and what is C sub y. So that's what you want to do. All right, pause your video, write it in your notebook, and let's see your answer. Okay, so now let us take a look at your answer. So the answer should be Cx is, sorry, minus 1, 2, 3. I forgot how to count. It's 3. And also Cy is minus 3. See, the only trick here is that this vector does not start at the origin, but that should not be a problem for you. And then we have 3 to the left, 3 down. So that's what this is, our component of the vector C. Okay. Now that's the that's when we have a grid and we can easily read those lengths. But this is the problem we often have. We know not where exactly what are the squares at which the vector ends, but we know how long is it. So we know the magnitude C, and we know an angle. And note that this angle is not a standard angle with respect to the x-axis. And so we do what we usually do. We write this vector as we want to know these components, Cx and Cy. And please note the following result. This you have to be careful to read. In the I direction, hey, this guy is negative because it points to the left, and it also is kind of pointing down. So this number is a positive number. The magnitude of Cx is positive, but then the vector C actually has a negative component. So that's what I wrote it as, minus the magnitude in the I direction, minus the magnitude in the j direction. So this is what we are going to use later. And then we actually are going to do the following. We do the rectangle as we did before, right? So there's your rectangle, and I took it out here. And we know that the angle we have is right here in this corner. So this is the angle theta. I just made it bigger here. And now let us try to get the vector, the component C. Aha! So what I'm going to do is draw. I put here in blue to make it even clearer this triangle right here. So there's a triangle right there that we are going to use. And let us take a look at this triangle. It has an angle theta. This is my vector. And here on the sides are the components. This is the magnitude. All this is the magnitude of Cy. And all of this is the magnitude of Cx. So you have a nice rectangle. And what we have in the hypotenuse, we have the magnitude C, no vector, just the magnitude C. So you have the two components and the magnitude. So let us use trigonometry. So now we have that triangle, and then opposite to theta is the Cx. So therefore, Cx is the magnitude C times sine theta, and the adjacent is the magnitude of Cy, so Cy is C cosine theta. So the final representation is going to be here. This is my final representation. This is the result that we want. It's minus C sine theta in the x direction, and minus C cosine theta in the j direction. And note that this is not what you expect if you actually take a standard angle with respect to the x-axis, because we had information theta given to us with respect to the negative y-axis. Oh, okay, I haven't forgotten about you. So please pause your video and find me the representation of D if D looks like this, and this is the information that you have. So you're going to write D vector equals to something here in the I direction plus something here in the j direction, and this is going to be your dx, and this is going to be your dy, and you're going to express all that in terms of the magnitude d, which is how long is this vector, and the angle theta. So do pause the video, work it out, and come back. Okay, all right. Okay, and this is the answer to the exercise. So in this case, we just count, and we see that are 5 units down. So our vector is minus 5j, and in this case, well, this is 3i rather, and minus 4j because we are in the negative y direction. So these are the two answers. It's the same vector, but the if we were to be a little bit more, just a little bit more careful with our notation, maybe we'll say w is equal to 3i prime. So this is the vector in the I prime in the new system of coordinates, and minus 4j prime, but I'm not going to do that. So we just saw that, and then that we can have two representations for the same vector. And one is easy and one is hard, but doing in this vector, maybe it saves us time because we then don't have to do many other more. So this is the tilted representation of my vector. And now I'm going to do the following. I'm going to take this this rectangle, and remember that we always draw rectangles, and I'm making a dance here. And what we are going to do is take that rectangle and make sure to draw a rectangle in such a way that it captures my vector. So it's going to capture the vector right here. And there it is. So you should be able to do that. You always should be able to draw a rectangle that fits with the axis and fits with the vector. It's right there. And then, well, this is going to help us a lot, because then it gives us this guy is just the x component of the vector, and this guy is actually the magnitude of this guy is the y component. So look at this. I took out the rectangle, and it is the x component and the y component. So there it is. This is our key result. And now, however, we need just a little bit more of information, because we want to express it in terms of the angle theta and the magnitude of the vector. Let me make this large. Okay, now we can see it now. Okay, let's move it a little bit. Okay. Okay. And there's one more. Let me make it bigger here. Should have a stop and do it in my own time. Sorry about that. All right, so but then there it is. And look, I have angles, right? And I know what these angles are. I do not know what these angles are. This is the angle of the vector in red, the vector w, with respect to the x-axis, and this is the angle alpha of the vector in red with respect to the y-axis. This y-axis is the same as this y, so that's why. But I put it there. So what's the relation between beta and alpha and theta? Hey, how about I give you an exercise? Oh, by the way, and these angles are the same here. So please note that alpha is between the red and y, and here's the same. It is alpha is between the red and the y. So that's the same angle as before. How about this? Let's do as an exercise. Try to guess what's the relation between alpha and beta and theta. Let me give you a hint. Alpha, one of those angles is actually theta. So try to guess it. At least guess it, but try to figure out try to see if you can figure out which one is it. Not just guessing, but actually thinking about it, looking at the geometry. Maybe do something and draw it. Or take a ruler to the screen, and maybe you can figure it out. Okay, I'll pause it. You pause it, and then try to guess it. Okay, what did you guess? Let me demonstrate the answer. Okay, so we're going to use geometry to answer these questions. Where is this angle theta? Right here. Ooh. Look at that. Ooh, it's moving back and forth, back and forth. So you should see that I moved the original horizontal that was here. Oh, I'm doing a very poor job drawing the horizontal, but it was here, and now I move it here. So now I got them closer. So that's the first thing you're going to do. And when you do this, please draw it correctly. And the hint is that this line here is horizontal, so that's why it's not hard to draw. And now we're going to do the following. What's the angle between x and y? Well, those are Cartesian axes, so the angle is 90 degrees. Therefore, this angle that I see here, if this angle is 90, this angle has to be 90 minus theta, because this is a right angle. It's 90 degrees. So that's easy. So I have a second angle here, and there's a bunch of other angles, and you can play with all of them. But we started with this one, and now we have this second one. And now we're going to repeat that trick again. Aha! Look, this black line is horizontal, this red vector is vertical. So there's again 90 degrees here. So, and if this angle is 90 minus theta, well, this is theta. Oh, and then we are home now, because now we figured out which angle is theta. So let us now just compare our pictures here. This angle theta is, which one of all these guys that is here? This angle theta is, let's make this bigger. This angle theta is my angle alpha, because it is between the vertical and the y. And here I have the vertical is red, and the y, which is not vertical, but it's right there. So alpha is theta. So correct answer is alpha is equal theta. There it is. Again, conclusion. And now we're going to use that information because now we know this angle is theta. This angle alpha is theta. So let us use that in the way we did it before. So I redraw this triangle here now, and then let's see what we have in this triangle. We have theta, which we just identified. We have wy, the magnitude of wy, which is in the vertical, not in the vertical direction, in the y direction. Wx, which is in the x direction, that's the magnitude. And this vector here, this magnitude here is w, the magnitude of the vector, the red vector. So your next exercise is to look at really hard at this triangle and tell me the relation between wy, wx, and w and theta. So write what is wx, the magnitude, write the magnitude of wy, both of them in terms of w. Let me move myself because you cannot see this. Or less, okay. Aha, this is the result. And let's see, this is my triangle, and wy is adjacent to theta, so it's going to get a cosine theta. And wx, the magnitude, is opposite to theta, so it gets a sine theta. That's your answer. So, but those were the magnitudes. So what is wx and wy? What are the components? Not the magnitudes. We just got those. But what is wx and wy? The point is you need to add signs. So do that, pause your video, and work out the exercise. Okay. The correct answer is that the x component is going to be, we got a moment ago that the magnitude was w sine theta, but now we can add actually the plus sign because, take a look, this is positive in this direction and this is negative in the y direction. So w sub y, the y component, is minus w cosine theta. So this is what we wanted. And now we can say that we know a x component, we know the y component, so the vector w is w sine theta in the I direction, in the x direction, thus the I, minus w cosine theta in the j direction. All right. So there's a couple other ways for you to think about the geometry of the system. Let me give you another way to solve the problem. So eventually what we want to do, like I said before, was to, once you're given this picture or you arrive at this picture through your analysis, you still want to draw these components. You want to draw your rectangle there, just like we have it here. And there's some angles there, right? So, and if you look at the names, this is beta and this is alpha. Draw nicely this rectangle. But those are your angles, and you want to know which one is theta. So let's look at another way to look at this. So the first thing you do is, hey, again, form a triangle, but let's form a slightly different triangle. So what I did was to extend my horizontal line, move things a little bit around, and now you should be able to see a triangle there. Right. And I shaded it in blue, and you should be able to see the angle theta there. Again, what we want is to get some of these angles that appear in this picture and relate them to angles that appear here. So the first thing I'm going to do is to note that this angle theta You might be able to see it here, but it's hard. It's not really obvious. But this one should be okay. So let us work in this triangle and obtain the complementary angle. And there it is. This is 90 minus theta. But that one you can actually identify. You're going to be able to see it. In fact, it should not be hard. Look at this. This angle here is between the x-axis and the vertical. And here is the vertical again and the x-axis. So these angles are the same. Beta and 90 minus theta are the same, and therefore you just take complements, take 90 minus these, and you get that the other angle has to be theta. So alpha is theta. Of course, the answer did not change. Just another way to draw a triangle that makes this clear. All right, so that's that. We're almost at the end. Now I'm going to give you an exercise. The last exercise is for you to write the components of the vector B. So let's say that for some reason we ended up with a force that was horizontal. But when we did when we look at this vector in the tilted axis, look at this red vector. It's exactly the same, but you look at it from two perspectives. So write the components of B and its final Cartesian representation. We still have a tilted axis with respect to by an angle theta. So pause your video and carry out the exercise. And now let's see the answer. The answer that you should get is that in terms of the magnitude of the vector, which is B, you have, let's see, look at this rectangle, nice rectangle, and you have a negative in the x, negative in the y, so that's why there's negatives there. And then from this, look at that rectangle, and this is horizontal. And then the angle theta, this is way too easy. This is here, and this is Bx, and this is By, and therefore, and this is 90 degrees, of course. So this rectangle triangle tells you then that, and this is the magnitude B, that the Vx, so it's adjacent to theta, so it's B cosine theta, and By is B sine theta. And therefore, putting it all together with the two signs we determined by I, and with this trigonometric relation, then we obtain this result. All right, so that's our video. Maybe if you didn't do the exercises, then watch it again and do the exercises. It's a good exercise. Even if you skipped doing the exercises before, just take a look again at the video and do the exercises. Or if you want to review it at a later time, again, just maybe you skip doing the exercises and then just went to the answers, but now you know how to do it. So please go back to the exercises, set a challenge to yourself, and you should be able to write everything down. Okay? Thank you.